Okay, to change a decimal to a fraction, you take whatever number they have here and you make that your numerator. So that becomes the numerator. And then whatever place value the number ends on becomes your denominator. So this is the tenths and this is the hundredths. So the denominator is 100. For this one, the fraction is going to be a mixed number because this is a whole number right here. Anything before the decimal to the left of it is a whole number. So this is the whole number, and then the fraction, you would do the same thing. This becomes your numerator, and then it ends in the tenths, hundredths. So it ends in the hundredths. This one is numerator becomes 3, and then where does my decimal end? It ends on the tenths. So our denominator is 10. This one, my numerator is 362, and then this is the tenths, hundredths, this is the thousandths. So that is my denominator. This one, my whole number is 43 because it's to the left of the decimal. And then this, I would do the same thing. My numerator becomes 1. And what place value does it end on? It ends on the tenths. So it's 43 and 1/10. And then this one is 0.1. We do, this is our numerator, and then it ends on the tenths. So our denominator is 10. All right, next one is percent. When I have a fraction, all I'm going to do is I like to turn it to a decimal, so it's 0.35, and then you move it over 1, 2, 35%. You move this over 1, 2, and you move it to the right. So it becomes 625%. This one you move 2 to the right, and you fill it in with a 0, so it becomes 30%. This one you move 2 to the right, and it's 36.2%. This one you move 2 to the right, you fill in a 0, and it becomes 4,310%. This one you move 2 to the right, and it's 10%. Now to change a percent to a decimal, so we have 35%. You moved the decimal 2 to the right when you were changing a decimal to a percent. So what we're going to do is we're going to change it by doing 2 to the left. So we're going to put an imaginary decimal that is behind every number. We're going to actually put that in, and we're going to move 2 to the left, and it becomes 0.35. Okay. 6.25 or 625, sorry, percent. We put our decimal in, and we do 1, 2, and it becomes 6.25. 30%. We put our decimal in, and we go 2 to the left, 1, 2, and it becomes 0.3%. And then 0.362. 36.2%, we would move our decimal over, and it would be 1, 2, and it would be 0.362. Does that make sense?
Yeah.
Okay. Assuming you're going to start algebra this beginning of the school year, 6th grade, second semester is usually order of operations, which I think you've already done. And then we have algebra. So I'm just going to go over the basics, very easy stuff at first. And this is how we see algebra. So you have a letter, and then you have a plus or a minus or a multiplication or a division. and then you have another number, and then you have an equal sign, and then you have what this part of the equation equals. So there are two sides of the equation. This part has a letter, and this part has a number. In algebra, our goal is to get the letters on one side of the equation and the numbers on the other. So I have a letter on this side, but I also have a number. So my goal is to move this 5 over to the other side. And in math, I can't just move stuff around, but there is a way for me in algebra to move it around. We say that they're adding 5, so to move it over to this side, we do the opposite of what they're doing. So what are they doing? They're adding 5. What's the opposite of adding?
Subtracting.
So we subtract 5. And anything we do to this side of the equation, we do to this other side. Remember, there's two sides, so we just minus 5 on this side. We're going to minus 5 on this side.
Okay.
If I have plus 5 and I minus 5, this gets cleared off, so I cross it off. And what's left on this side is an A. So I rewrite the A, and I write my equal sign, and then I do the math here. 10 minus 5 is what? 5. So A equals 5. Now, we would be able to rewrite the equation that we originally had, and we would plug in a 5 every time we saw an A. So for this problem, we just have one A. And obviously, we could have figured that out just by looking at it. Something plus 5 equals 10. And that's true. We could just say, well, I already know that it's 5, Anne. Why do I have to do all of these steps? Because it's not going to stay that easy. So this is how we have to do it every time, even if you could see that the answer's 5. You have to show your work by doing these steps. First step, you write the equation. Second step is you do the opposite so that you get the letters on one side of the equation, which is the equal sign, and numbers on the other side of the equation. So when they're doing something, you do the opposite, and that moves the number over to the other side. Anything you do to one side of the equation, you do to the other. And then that is exactly how you do algebra 100% of the time. There's going to be more steps when you start to get into different equations that are trickier, but that's always what you come back to. This is all of everything in algebra. So now we do the math, and then you write what the letter is at equals, and then whatever the math comes out to be. So that's the last step, which is what I did here. So it would be nice if it stayed that easy, but it doesn't. So we're going to see, you might see something that looks like this. A minus 5 equals 10. So I could see right now that the answer is 15. I don't need to do anything to get the answer, but I do need to do something because this, if you just wrote 15, that would be incorrect. You would have to show how you got the answer in algebra. So we're going to follow our same steps. First thing is we write the equation, which I did. I'm going to do the opposite. They're subtracting 5, so I'm going to add 5. And then anything I do to one side, I do to the other. So this cancels each other out. What's left on this side is A, and then 10 plus 5 is 15. Now I plug it back into the original equation, which was A minus 5 equals 10. 15 minus 5 equals 10. Is that correct? Does 15 minus 5 equal 10? Yes. Yeah. So you know that you did it correct. If you got, say for some reason you did the math wrong and you got 16, then we would say 16 minus 5 equals 10. Is that true? No. 11 minus 10 does not equal, right? this number and this number, when you plug into the equation, have to be the same, or else you did something incorrect.
Okay.
It would be nice if it stayed that easy, but it doesn't. So the next step is multiplication. So 5a equals 50. When they write a number with a letter like this means multiplication. So this is basically like 5 times a. They just don't write it. And the reason why they don't write it is because sometimes your letter is going to be x instead of a. So what would we do if it looked like this? That doesn't look right. So instead, in algebra, instead of using the multiplication like we've always done, they use parentheses, or they just stick it next to a letter and a number together, or sometimes they show it like this: 5 times a. You've seen that before, right? Okay. So for this, we know by looking at it that when a 5 or a number is stuck with a or a letter, that means multiplication. What is the opposite of multiplication?
Division.
Yeah, so we're going to divide, and in algebra what we do is we show it as a denominator. And then we know there are two sides to the equation. What I do to one side of the equation, I do to the other side. So this cancels each other out, because what is 5 divided by 5? It's just 1.
1. Yeah.
So on this side, all that's left is an a. And then on this side, what is 50 divided by 5?
10.
Yep.
Or, no.
Yeah, that's right.
Oh.
Now we see our equation is 5a equals 50. 5 times 10 equals 50. Is that true? 50 equals 50. Yes. Okay, so I'm going to have you do a couple. I just saw the text from Mom right when we started saying you were kind of not ready to start in on stuff. So we'll just take it easy today and do this video, and then you can watch it at home. And then we'll just do a couple of easy problems and we'll walk through it. So let me stop this and I will send it to Mom.